I want you all to steal this dynamic programming problem solving trick of mine. It is so cool that I almost feel bad giving it away for free. And I think very few people know about this Python trick which makes doing dynamic programming problems so much easier. People tend to struggle with dynamic programming because of how intimidating it looks. But most dynamic programming problems can be solved with a fixed two-step process, and if you nail these two steps down, I bet that you can do 80% of DP problems. And those two steps are, number one, recursion, which is basically coming up with a recursive solution where you figure out a base case and then fill in the rest. And then step number two, which is memoization, which is just a fancy word for saying remembering previous results of a function call so that you don't have to compute it again in case you need the results again. Now, this trick is going to reduce the second step, which many people struggle with, into just one simple line of code. And that is the add cache decorator in Python. We can memoize our function results using this decorator. So here I have this simple problem called the minimum cost of climbing stairs. Let's understand it first. The basic premise of this problem is that there is a staircase and you can start climbing from either the 0th or first step, and then by paying the cost at a particular index in that array, you can choose to either climb 1 or 2 steps as per your choice. You have to find the minimum cost to reach the top floor. Can we write the recursive function for this? Let's do it together. I'll take the length of this staircase and store it in n, which is the length of this cost array. Now remember I said you can either start at the 0th or 1th index, and I'll just call the solve function, which we haven't written yet, and call it from two places, the 0th index or the first index, and I'll just, whatever the minimum result is, we'll return that to the calling function. Now let's define this solve function, which is going to be the step 1 of that process, and a recursive function. So here I have initialized the recursive function. It will have this index variable which will be passed to it, which I'll call I, and let's write the base case first. So if we have already reached the top of the staircase, there is nothing else to be done, so the cost will be 0, right? But if, let's say, for whatever reason our recursive function overshoots this boundary, that basically represents an impossible test case, and for that, if the I is greater than n, I'll return infinity, which basically is a very high number so that it doesn't get calculated in our minimum cost calculation. Now for every other case we will have two options. So the result will be the cost at the current index which you are paying, because you have to pay to climb at least this current stair, and then the subsequent cost will be the minimum of two possible options, which is solve for I plus 1 or solve for I plus 2, because you can either climb one stair or two stairs at a time. So let's see if this works. Yes, the test cases are passing. Now if I submit this right now, you will basically see an error which sort of says that there is a time limit exceeded, which makes sense because we haven't memoized it yet. So every time it needs to calculate something, it is doing it from scratch without storing any results, right? So at this point, most people would declare a hash map or some sort of an array and start storing results of previous computations for the next steps to use it. But in Python, you can just add this decorator of add cache, which will basically remember every possible value with which solve was called in the past, and its result will be returned if it is called a second time from memory instead of computing it from scratch. Now let's see if the result passes again. I've only changed one line of code in this, right? So this is already passing now. So this is a very magical trick, right? If you are crunched for time or you're in an online assessment, this sort of trick can save you minutes. So here I'll show you how to use this exact trick in another problem. So this is the more advanced problem, and it's called the house robber problem, which basically says that there is an array of numbers which represents the amount of money in a road full of houses, and you have to find out what's the max possible robbery amount you can rob without ever stealing from two adjacent houses. Because robbing from two adjacent houses will lead to the cops getting called and you getting caught. I have already written the recursive solution here like in the last example, so I won't bore you with it. But you will notice that if I don't add the add cache decorator, this is just a simple recursive function, so it will not pass. It will give us a time limit exceeded error. So we have received a time limit exceeded error. Now once we add back the add cache decorator, it should pass. Right. One thing to note here is that this trick only works if your inputs to the solve function are hashable, or data types which basically don't change. But that's something interesting that we can dive into some other day. If you want to learn more about what's hashability or get resources on how to get better at recursion, I have made a cheat sheet with a list of curated problems and resources where you can test this add cache decorator out for yourself and learn dynamic programming in the process. If you're interested in getting your hands on this cheat sheet, check out the link that I have posted along with this video. I hope these tips help you. If they did, share it with your friends who are trying to get better at lead coding. Also, feel free to let me know in the comments about what else I can help you with next. Thank you.